We're here to talk about smart contracts on Bitcoin. And when I say smart contracts to most people, I know Bitcoin isn't what comes to mind immediately, but we're here today to change that conception and talk a little bit about the things that people are doing with Bitcoin scripting language with smart contracts today, and all the proposals and technical work that's going into enabling richer, stateful smart contracts that work with our favorite currency. So I'll let our panelists introduce themselves briefly and talk a little bit about the work that they've been doing on smart contracts.
Excellent.
Who's going first? My name is Max. I'm with Hodl. We're a peer-to-peer non-custodial exchange. We use Bitcoin-based smart contracts for BTC trading.
My name is Diego. I'm from RSK. We created a second layer on top of Bitcoin, merge mine with Bitcoin, that enables statefulness, Turing-complete scripting. So you can run any Ethereum application secure, on RSK without any modification, but secure by the Bitcoin network and run with smart Bitcoins.
My name is Andrew. I work at Blockstream. At Blockstream, my colleague Russell O'Connor has developed a language called Simplicity for smart contracting, which is a very general, very powerful language designed for high assurance for creating mathematical proofs of correctness. Also at Blockstream, my colleague Peter Willa and I have been working on a language called Miniscript, which is effectively a visual representation of Bitcoin script. And because it's simply a representation of Bitcoin script, it's actually something that's usable on the Bitcoin blockchain today.
And my name's Tyler Evans. I'm a co-founder of Echo, which is a project building a bidirectional peg sidechain to bring more smart contract functionality using Bitcoin as the native asset. So Andrew, I want to start with you and talk a little bit about the ways that people are using Bitcoin scripting language today and to build types of spending conditions and contracts, if you will, on Bitcoin script.
Sure. So what many people who use Bitcoin or are familiar with Bitcoin are maybe not aware of is that Bitcoin contains a full scripting language. We typically think of Bitcoins as being controlled by keys. To spend your Bitcoin, you need to sign with some secret key that you're storing. But what's actually happening on the technical layer is that when you spend Bitcoins, you're actually satisfying a script. And there's a standard script that most everybody uses that simply checks for a signature with a specific pub key, so we can kind of abstract that away and pretend like the coins are controlled by the keys. But the truth is the coins are controlled by the script. And the script is written in a language called Bitcoin script, which is a fairly general, fairly powerful, and I'll try to give describe some limits on that in a sec, stack-based machine language. What that means is that these scripts are written as a series of opcodes, like in machine language, and validators of the Bitcoin blockchain execute the Bitcoin script engine. They follow all of these opcodes, and they rearrange different stack elements. They can check signatures and stuff. And as a result of this, they can do a lot of different things. They can do not only signature checks, they can do threshold signature checks, where, for example, if you have 2 of 3 participants, and any 2 of them, you have 3 participants, any 2 of them want to be able to spend coins, you can do something where you require revealing a secret. You can require the coins not be spent until a certain amount of time is up. And you can do arbitrary combinations of this in various elaborate ways. And so let me give 2 specific examples of where you might use this. One is there is a form of wallet software known as a non-custodial wallet, where you have your coins partially stored. The coins are ultimately in control of the user, but there's a wallet provider who also has some partial control, some partial temporary control of the ability to spend the coins. So an example of this is a product at Blockstream we have called Green. This is a wallet you can install on your phone. And the way it works is that after a certain amount of time, if the Green service is down or it's not cooperating or something, then you're able to spend your coins using two keys. One of which is on your phone, and if you lose it, if you get stolen or something. Another one you can keep backed up elsewhere. Under normal operation, you sign with 2 signatures. One signature is provided by your phone, the other is provided by the Blockstream Green service. And what this allows you to do is if your phone is stolen or something, if you lose your keys or you lose control of your keys, then the coins are no longer lost. And the way that's done technically is that on the blockchain, there is a threshold signature, 2 of 3 participants. 1 is Blockstream, 2 of them are you, basically is how it works. A more elaborate example is the use of Bitcoin script to do atomic swaps. I'm going to get like a little bit technical here.
Here we go.
So an atomic swap is a way of producing 2 transactions on 2 different blockchains, such that either both of them are complete and they're both valid, or neither of them is. Okay? And the way that this is done, using Bitcoin script and other similar languages, is that there is a secret that needs to be revealed. So, well, first off, you have 2 participants. The first thing is that the participants need to move the coins into play. Perhaps we're trading Bitcoins for Ethereum or something like that. The participants need to move their respective coins into control of a script that encodes the semantics of the smart contract. And what that script does is it says these coins are not allowed to move unless either some timeout is up, and I guess the contract has failed, and then people can just move their money up. That's not so interesting. Or the first participant signs and also reveals a secret. Okay? And the blockchain enforces that this secret is revealed. And the cool thing here, and this is what makes it atomic, is that the secret is the same on both sides. And that means that when one party signs the transaction, produces a transaction to take their coins, say I'm trying to trade Ethereum with Diego for some reason, and let's say, well, I don't want Ethereum, I'm sorry, so you have to take the Ethereum. When I take my Bitcoins, the blockchain requires that I reveal some secret. Diego can look at the Bitcoin blockchain, he can see that secret, he lifts it off, and then he uses that. So originally he didn't know it. He just copies the secret over, and he can use that to take his Ethereum. Okay? And the idea here is that if I didn't reveal that secret, of course he wouldn't be able to take his coins. But the trick is I can't get my coins without revealing a secret. So we're kind of using the blockchain as a communication layer in order to communicate, to make some knowledge public, and therefore make it so that when one transaction executes, the other one can as well. And that's something that people are using Bitcoin script for today.
Mm-hmm. Nice. Yeah, I would love to do that atomic swap with smart Bitcoin. So I can give you some smart Bitcoins, you give me some Bitcoins back. So in the case of RSK, what we have is, I would say the main difference is that, well, I would say there's many main differences. One is that the programming language is Turing complete, but I don't think that's the key. I mean, indeed, I think it's better to go in the direction of DSLs, of domain-specific languages, because that reduces, the possibility of making a mistake by the programmers and losing funds. And so I think a more restrictive language, built around on specific domain would be better. The good thing is that as RSK is Turing complete, you can create those DSLs within the current environment. And there are some frameworks that are building those DSLs. And also, which is key, and I think is the main difference, is that you have statefulness. What it means is that you can, make decisions on one script based on the output of previous executions of a script. So you can chain, the decisions of multiple scripts over time. So that's one of the, that gives the developers more flexibility. A simple example of that is you can create a wallet that can spend, up to 1 Bitcoin per day. And you can, within the script, restrict that thing. Another use case that is very interesting is that you can make a kind of an escrow contract where you leave certain amount of smart Bitcoins in custody, and you say, these Bitcoins will be released based on changes of states between these parties that we will feed to this contract. So we can do, for example, play chess. So I give you my first move. On top of that, you build the first move. So all those interactions are peer-to-peer. Once we come to a final state, that is whether you make a checkmate to me, we can feed that to the contract, and the contract will release the funds to my account. So you can do, that like off-chain execution that will be guarded by an on-chain smart contract. And you can delay also the actual, and we can have a fail-safe where we say, if there's no agreement on the final state of the situation, we will deploy this contract that will have the full off-chain logic that we were using to enforce the contract. So I can never escape, abiding by the interactions that we have, but we don't have to impact every interaction on the chain. So that creates a scalability, so you can have business logic that can process the needs of millions of users without needing the on-chain scaling and bloating the blockchain, which is one of the main problems in the blockchain environments. It's like you want to keep the blockchain as small as possible to make it sustainable over the years and to be able to scale and serve. So that's the kind of flexibility that we bring into the Bitcoin ecosystem by creating a second layer that has different data structure. Also, the validation, the blocks are issued every 30 seconds instead of 10 minutes, so you can interact with the blockchain faster. That's good for setting up payment channels. It creates kind of what Lightning is doing in Bitcoin. In RSK, you can do it with Lumino, and you can set up routings. The routing discovery is more efficient. So you have some more flexibility, of course, at the trade-off of certain security. Of course, Bitcoin is still the safest, consensus protocol and blockchain, and needs to be because it's a store of value. But in our vision, what we are doing is building a layer on top that goes, and you separate, you do responsibilities, between layers. So RSK is focused on agreement settlement, while Bitcoin is focused on a store of value and transfer of value.
And Max, could you talk a little bit about how you guys are using Bitcoin smart contracts at Hodl?
Yeah, so in case of Hodl, we use the simplest form of Bitcoin smart contract, which is multi-signature addresses. So when a trade occurs on Hodl between two parties, we create a unique escrow multi-signature address on the Bitcoin's blockchain. Seller sends Bitcoins right from his wallet to this escrow address. As soon as Bitcoins arrive to this escrow address, we inform each party involved in the trade that they're locked in. And buyer just sends the fiat, and then these coins are released directly to the wallet of the buyer. The escrow works by the system 2 out of 3, so you require 2 signatures to release coins either back to the seller if he didn't receive any fiat payment, or to the buyer. And Hodl owns 1 key, seller owns 1 key, and the buyer owns 1 key. So in case of a dispute, we come in and we can effectively move coins either in one or in another direction. We also use the same approach, but with different scheme for our prediction platform that we just released on Monday. And actually, for us, multi-signature addresses is proven to be like the most efficient and the simplest way of doing business. You can literally do a lot of stuff with that type of the contracts.
And Andrew, I want to talk a little bit about some of the different proposals out there, some of which are kind of progressing through the BIP process for enabling more complex scripts and new types of data structures and scripts on the Bitcoin blockchain. So we've got Snore Signatures, we've got Taproot, and we've got Mast. Could you give a little bit of an overview of those technologies and how they would impact the ability to build these types of scripts?
Sure, absolutely. So the proposal that's been in the news lately is something called Taproot. And Taproot actually is a catch-all name for everything you just mentioned. So all of the new proposals for Bitcoin that affect its scripting language, at least the ones that are in play today, kind of fall under this umbrella of Taproot. So the first thing, the simplest thing that Taproot is it represents every single Bitcoin output rather than by a script, as I described, but by a key. So it actually goes back to the intuitive model that a lot of us have in our heads, where coins are controlled by keys. You produce a signature with the key to spend your coins. And this sounds like a step backwards, of course. Like, why on earth would we revert from this very general thing to something key-based? And here's the cool part about Taproot, is that Taproot actually has the ability to commit to an arbitrary script inside the key. So there is a key, and you can spend the coins by signing with that key, but optionally, you can instead reveal a script, satisfy that script, and spend the coins that way. And the reasoning for this is that there's an observation that has been floating around on the Bitcoin development mailing list and in the Bitcoin community, that in typical uses of contracts, there are a fixed, known upfront set of counterparties. And if all of the counterparties agree that the coin should move, then there's no reason for them to go to the blockchain and ask the blockchain to verify that the coins could move. All they need to do is jointly produce a signature. And so we can come into now the second technology that's part of Taproot is this thing called Snore Signatures. So today, the digital signature that Bitcoin uses is something called ECDSA. Taproot, when it requires signatures, rather than using ECDSA, it uses something called Snore. The advantage of Snore is that it allows a fairly simple protocol that allows multiple parties to produce multi-signatures or threshold signatures together. So, for example, if you're doing the 2 of 3 kind of things that are done by Blockstream's Green or by BitGo or by Hodl or what have you, rather than having a contract on the blockchain saying, I want a signature with this key, a signature with that key, a signature with that key, it simply requires a signature with a single key, and that single key jointly represents all of the different participants in the contract. And all of those participants are able to interactively produce a single signature that causes the coins to move. And what this means is that if you have a Taproot output that can be spent by a single key, this may represent some complicated smart contract. It may have a commitment to some sort of script inside, but in the cooperative case, in the case that your counterparties all agree that the coins need to move, then they can jointly produce a signature, and the blockchain doesn't need to see multiple signatures, first of all. The blockchain can't distinguish that there's one party or multiple parties, or maybe some threshold, some complicated 2 of 3 thing, or even arbitrary tree that could be like me and Diego or Max or something like that. You can encode this all in single keys. So it's nice that the blockchain doesn't see that, but more importantly, the blockchain doesn't see whatever script conditions we have. So we may actually have a complicated contract that uses blockchain rules to enforce that the coins only move under certain conditions. But only if we can't agree amongst ourselves to produce a signature do we need to use that. And in that case, we reveal the script. The blockchain verifiers can see that it is a correct script that was hidden inside of the key, and you spend it normally. But the cool part is that under normal conditions, you don't reveal that the script exists. The validators don't even, they can't distinguish between one party and multiple parties, but they can't distinguish between complicated contracts and ordinary single-person wallet contracts. And then the third thing you mentioned is masked, which I'm not going to go into. That's more or less a technical thing that allows different branches of the script to be independently revealed.
And it has privacy implications for being able to not have to reveal all of the spending conditions.
Because you're not giving away who signed, who were the signers, although you know the funds are good to go. And also, it's very efficient when you have a big pool of participants. It's like, it gets extremely efficient when you have more. And like now in Bitcoin scripting, you can do maybe up to 15 multi-signature participants. With this, you can have thousands. And in terms of the bloat on the blockchain is highly reduced. So it's a very good thing because now you can have multi-sigs with many participants.
But still only one signature.
Yes, you can do random selection. I mean, this complex smart contract that you have offline can do random selections of participants. So it's much harder to attack, that group of people because you don't know exactly if you attack this group, if it will be, enough to really co-opt the system. So you can do very interesting things with the aggregation of signatures that was Snore is doing. There's another, BLS is another.
Right, so, so BLS signature is something that is probably not going to be proposed for Bitcoin.
I know, but
it allows similar aggregation capabilities.
So it's very, very exciting.
And you started going there, Diego, but what are some of the types of new kind of complex spending conditions and contracts that people will be able to build with these threshold signatures and these technologies on Bitcoin?
So I can take that. I don't want to dominate the entire panel. So the first thing, as Diego mentioned, because we're producing single signatures in a multi-party computation, that's like a scary word. It's actually a very straightforward protocol. Everybody produces their own signature. You literally add them up like you would in grade school, and then the sum of the signatures turns out to be a valid signature. This allows you to scale from the, I believe it's 15 limit that's in the current Bitcoin multi-signature opcode to arbitrary numbers, because it's not, blockchain validators are not your bottleneck. It's however many people want to come together and set up a giant protocol, they can do that. There's no limit. The second thing that Snore Signatures enable, and actually, so this is kind of cool. Taproot includes a new variant of Bitcoin script that replaces ECDSA signatures with Snore Signatures and a couple other minor things. But actually, the script itself doesn't really give you any more expressivity beyond breaking these limits. But what does give you more expressivity is the use of these Snore Signatures in the main Taproot branch. So I've mentioned how you can use Snore Signatures to, or by jointly producing Snore Signatures, you can get multi-signatures, you can get threshold signatures, you get arbitrary combination of the keys. That's pretty cool. But another thing that you can do in Bitcoin script today that seems like you maybe can't do with just signatures is this revealing of secrets. So I mentioned that if you're doing an atomic swap, you have two independent chains, you have to reveal a secret on both chains. And the idea is that if one transaction is created, then another one automatically becomes valid. And intuitively, this seems like overkill to use the blockchain for this. Because in the example I gave, I revealed a secret to the Bitcoin blockchain. Diego copied it off the Bitcoin blockchain and used it in his own blockchain. Why do we need to go through a blockchain? And the reason is that the blockchain is the thing controlling the flow of funds, right? If the blockchain wasn't enforcing this, then I could just take the coins and run away and not reveal anything. So the other thing you can do with Snore Signatures, and this is really cool, is when Diego and I are interactively producing a Snore signature, say to give me my money, before I start the protocol, I can encrypt a secret to him. And I'm going to use my signature as the encryption key, okay, my part of the signature. And now, Diego is free to sign to give me my coins. Then when I combine my signature with his, when I sign to take my coins, he sees the signature on the blockchain, which let's remember is combined with me, so there's one signature that hits the blockchain. He sees that signature, is able to use that as a decryption key, and he learns a secret. And then on the other side, he's able to use that secret and transform it through something called an adaptive signature into another signature of mine, giving him his coins. So now we've encoded this secret communication thing that previously was using Bitcoin script. Now we've been able to hide that inside of the signature itself, which means even if you're doing complicated things like atomic swaps, then all you need to do, or all Diego and I need to do, is produce a single signature, and that's all the blockchain verifiers see. So that's the capability that you currently don't have, is to reveal a secret in the way that the blockchain is not aware that a secret's being revealed. It can't tell that the two secrets involved are the same. I mean, it can't see any secrets.
Yes. So that
obfuscates from an outsider that is not part of that deal what's going on.
Yeah.
So you can mask different types of interactions, and people from outside cannot tell what those interactions are. So it stops certain mass surveillance models that can be done otherwise.
And this technology is also used, by the way, in Lightning channels. Lightning payment channels have a bunch of two-party atomic swaps, and each of the atomic swaps is linked to each other using a similar revealing of a secret. So one channel updates. In order to do so, it reveals a secret that allows the next channel to update, reveals the secret to let the next one update, and so on. And
I think they're proposing that for spontaneous payments, no? There's a proposal.
There are a couple of proposals for spontaneous payments, and I'm not too familiar with any of them. But right now, because we're using hashes and hash primitives on the blockchain, I apologize for being technical, it requires you use the same secret for an entire payment path, which is very bad for privacy. And what these adaptive signature-based, these Snore signature-based secret reveals do is not only do they prevent publishing this to the blockchain, they allow the secret to be re-encrypted at every hop. Which means that if you're sending coins through me to Max, back through me somewhere, I can't tell that I'm the same person. I can't tell that both of those
it's kind of an onion routing model where you only know, and in this case, it's split by transaction and not even by trunk or channel. So no, it's very interesting from a privacy perspective. I think it's very powerful as well.
Well, we've spent almost all of our time talking about layer 1 smart contracts on Bitcoin. In our last couple minutes here, let's jump into side chains and layer 2 approaches to add functionality to Bitcoin. And Diego, would you jump in here and give us an overview of kind of the current technology?
Well, I think the key of why second layer solutions like what we are doing with RSK and side chains in general, like what you're doing with Echo, is that we can innovate and we can research like more. We can take more risk than Bitcoin by itself can take, because it's like indeed, for example, we have our own consensus protocol called Decor Plus that has blocks every 30 seconds because there's no orphan blocks, so even miners come at the same time, they will get rewarded. So you can have like shorter times of confirmation. So that enabled us to do a lot of interesting things in terms of exploring different consensus protocols, different compression techniques on the blockchain, third layers. Now we are working on third layers like Reflumino payments and so on. So we can, one of the things we are doing now is like an engine to do share economies on the fly. So anybody can create their own share economy, and have reputational models where reputation information is portable, unlike in the Uber systems where Uber keeps the reputational information. Now the individuals can have their reputation and use it in other share economies. So I think the most interesting thing is that we preserve the core values of Bitcoin, censorship, resistance, maximization of security, and we can explore more complex interactions in a decentralized way, but sacrificing maybe some of the security aspects of Bitcoin, for nimbleness and more expressive programming languages and so on. So I think that's the core of why with layer 2, we are going from, I think this narrative that Bitcoin is only a store of value or a remittance network is going away, because the Bitcoin ecosystem is a full-fledged Internet of Value, as I like it to call it.
Settlement layer for the Internet of Value.
Yes. So, and that ecosystem is starting to grow, and people are starting to see that the Bitcoin ecosystem can be the full thing. It can be like this financial system of the future, open financial system of the future that will protect our value, our privacy, and everything else. So
wonderful. That is all the time we have, but thank you guys so much.